Hi everyone, I'm Anish and welcome to PrepFusion. So today we will be starting a new chapter, that is the block diagram and signal flow graph. So like in this chapter will be very small only, okay. The content will be very less amount of hours. Just we have to understand how to reduce a block and how to solve a block, right, block diagram. And if we can't solve it with block diagram, then we will take the help of signal flow graph. So first we will learn block diagram, then we will learn what is a signal flow graph. So in this lecture, right, this is the lecture 1 of this chapter. So in this lecture we'll understand what is the need for block reduction, okay, and different block reduction techniques, the rules that we use, okay, and questions related to these concepts, right. So first we have to understand, like, why do we need block reduction, right? Why do we need it? Because we have to simplify the system, right? There are many subsystems connected with each other, okay. Let's say there are many subsystems. Okay, my pen is not on, just hold on a second. Yeah, many subsystems that are connected with each other, right? Like this, then there is some adder. Okay, there are many subsystems that are connected with each other, but what we need to do is simplify so that we can easily analyze the whole system, right? Okay, many subsystems are there, but we need to simplify it so that we can analyze the whole system, okay. For that reason we use block reduction techniques. So one more thing you have to note is that obviously this block reduction technique will only be valid for LTI systems, okay. So this was the need for block reduction technique. So need for to further simplify, I forgot the feeling, subsystems and to reduce it to one block, right? One block for easier analysis. Okay. Also, one more thing we have to keep note is that this is only valid for LTI systems, okay, only valid for LTI systems. So here this is the definition of block diagram. So what is a block diagram? Block diagram is a pictorial representation of a system. Basically, if we have a system, right, so we have to somehow explain it to someone else, right? So we know the equation, but how do I visually show it to him? So we saw there is a controller, there is a planned transfer function, then there is a feedback. That is basically the pictorial representation of a system that we were doing from the lecture 1, like the first chapter itself. But obviously everything can't be done in like one lecture itself, right? So we are going from bit by bit, okay. So this is what a block diagram is. So block diagram, like reduction technique, is used for determining the overall transfer function of the system, overall ratio, right, transfer function of the system, right. We will use reduction techniques to further simplify the block diagram. So one thing to note here is that we'll have few set of rules, okay, but don't worry, we will not have to remember those rules. I will tell you how to reduce a block, right, how to further simplify the block diagram, okay, that I will tell you. So first rule is the representation of closed loop system. So it has two parts, one is negative feedback and one is positive feedback. So already we have proved it, okay. So you have to remember it. What is the transfer function for this block diagram, right? If I convert this into a single block, right, let's say the block has a gain G dash, okay, and this is C and this is R. So what is the transfer function for that? It is simply G upon 1 plus GH, right? So C of S by R of S equals to G upon 1 plus GH. Okay, so this is the transfer function. Now if it is a unity gain feedback, then it becomes 1 by 1 plus GH. So this G dash, right, G dash becomes this one. So these thing you have to keep in your head, this thing you have to remember, right? So now we'll go for the positive feedback, right? Again, if I want to convert this, let me take another color, into a single block, right? I want to convert this into a single block. Let's say this is G dash, right? So again, what will be the G dash this time? So G dash this time will be just the sign will change, right? It will be G upon 1 minus GH. So C upon R equals to G upon 1 minus GH. I am not writing the S bracket S here. It is understandable. It is understood that yeah, it is a function of frequency. Just to like not mess the my writing pad. That's why I am not writing bracket S, right? Okay. So this is what G dash is, positive feedback. Now we'll go to second rule. The second rule is cascade connection. Now if two blocks, right, if they are connected in cascade, then what will be the overall, if you convert it into one block, what will be the overall gain of that block, right? So like we already know it that we simply multiply it, but how do we get it, right? So what I will assume here is I have a output X here, so X by R equals to G1, right? Now this C by X equals to G2, right? The gain, what does the gain of a block represent? Output by input, right? So G2, G1. Now I have to find C by R, right? C by R. So if I want to find C by R, what I'll do? I will simply multiply those two, and there is no loading effect. Okay, this is another important point to note, is that there is no loading effect in cascade connection for block representation, right? So for block representation, no loading effect. Okay, so what will be the overall transfer function? C by R, it is X by R times C by X equals to G1 upon G2, right? G1 upon G2. So this is the overall ratio. So I can replace this whole block, right? Replace this two blocks with a single block only. So this is how we can replace this whole block, right? So if two blocks are connected in cascade, they will be simply multiplied. The gains will be simply multiplied. Now if two blocks are connected in parallel, what will happen? Simply, what is our output? So what is the value of this point here? This is R, right? So R is getting multiplied with this one and with this one. Then we are here we have R into G1, here we have R into G2, and this is getting added here, and this is getting added here. So C equals to R into G1 plus G2. Okay, so let me take this to another. Okay, let me write over here only. So we have R over here, we have R into G1 over here, we have R into G1 over here. So what do we have? R into G1 plus R into G2, right? So C equals to R into G1 plus G2, right? So what is C by R? C by R equals to G1 plus G2. So we can further replace this whole combination with a single block, that is G1 plus G2. Okay, so let me take another page. Let me so what will be the the block diagram for this? So what I will write here is this is C, this is R, and this is the equivalent, right? Equivalent of this one. So this is G1 plus G2, right? So this is one rule 3. I hope you don't have to remember this, like you can just see this, right? But these things are pretty simple to remember, so like these things come into your head anyways, and I hope you already know this rules previously, but our next few rules maybe but new to you. What is this new point? This is the shifting of takeoff point before a block. Takeoff point, the point where I'm taking the output from, right? So this is the takeoff point. So what I need to do, shift this point, right? Shift this point to before the block, before the gain block basically. So what we have to keep in mind is that whatever was the output of this takeoff point, right, this should remain same also here. So what was the output of this takeoff point? So what rule we have to keep in mind is that output of takeoff point should remain same. So like why do you want to shift this to here? There may be some bigger block diagram, right, and we have to shift some point to another point to further simplify our like block diagram. We'll understand this while we solve the question. So that is the reason we may want to shift from here to here or from here to here. That is the reason, right? So if you want to shift from here to here, one thing you should keep in mind is that this should not disturb the system. So whatever output I was getting from this point, right, from this takeoff point, the same output if I take from this point I should get, right? So what do I need to do? So what was the output that I was getting here? So here, right, I was getting the output as, okay, let me take another color. Okay, white is good only. So this is R, right, R times G. So output was R times G, right? So here also if I take the output I should get R times G, but now if I take simply the output from here, right, I am getting only R. So I need another gain block of G so that I get R times G. So what I will do here is I will place another gain block here and take the output from that gain block and I will get R times G. Okay, that's the reason there will be a gain block here, right? I need the output same, right? Same output I need. So let me copy this. Okay, what did I copy? Something else got copied. Okay, so if I take the output from here, right, so what I need to do is place a gain block here, because here we have R only, right? So I need to place a gain block. I don't know what that gain is, but that gain I understand that gain should be G only. How? Like here what was my output? It was R times G. So here also my output should be R times G. Okay, so what should be the gain here? The gain here should be G only, right? So if the gain here is G only, then I will get my output as R times G. So that is how we can replace, we can shift a point, right? We can shift a point, take off point from this point to this point, right? So yeah, this is one very basic understanding. So let me like draw this a bit better. Okay, this is drawn already better only. So let me cut off these points. These were just to show to you, right? This were just to show to you, and like explain to you. So here we have one point Y. So this Y point has been shifted to this point, right? Y has been shifted to this point. Okay, so yeah, this was basically it. Now let's get for the solve for the next rule. Here just one thing you need to keep in mind is that block, if you want to shift before, right, block gets multiplied, but you don't really remember this. Still I am writing this, block gets multiplied, right? Block gets multiplied. Now what I want to do now is that shifting of takeoff point after a block. Basically takeoff point is here, I want to shift it after a block. Instead of shifting it before a block, I want to shift it after a block. The flow is this one, right? Flow is this, that's why. So what I have to do is shift it after a block. So what is the output at this point? At this point, what is the value of that takeoff point? It is R only, right? It is R only. But what is the value here? What is the value here? It is R times G. So I want R, but we have one extra gain, R times G. I need R only. So I will put some gain, something like this, that it cancels the G term, right? It multiplies with R, it cancels the G term. So what I will do is, let's say this is like, let's say this is some gain of X, right? Some gain of X, okay, but output I want R, okay, because this output was R only. So this point, what is the value of this point? It is R into G. So I can write the equation, right? What I can write is, let me take R times G times, okay, this X will get confused, okay, this is X only, equals to R. So what will happen? So what will the value of X? So X will become 1 by G, okay. So gain block gets divided, right? So basically what I can do is, this gain block, right, this is R only, right? We're writing R only. So this block will get divided, okay. So let me highlight this, will get divided, okay. So if you want to shift it back, right? So yeah, this was the rule 5. Now let's do the rule 6. So rule 6 is shifting of takeoff point before a adder. Now adder, I hope you know that we're adding two variables, right? We have to shift this takeoff point, right, this point before a adder, right, before adder. So how will I shift it? Basically what I will do is, simply what is the output here? The output here is R1 plus R2, right? So if I take some point here from here, that should also be R1 plus R2. So I will need one extra adder, because what is the output currently here? The output currently here is R1 only. The output currently here is R1 only, okay. So I need an extra R2 term here to get my desired output, right? That so that it remains same even if I shift this takeoff point. So what should I do? I need one extra R2 term, right? What I will do? Simply add that R2, right? Simply add that R2. So let me take this block diagram again, okay. So as I am shifting this, let me take this back a bit. This one, okay. So what I will do is, I am taking this point from here, and I will add, like we will need an extra adder component that will add R2 also. So from here we will get our output, which is R1 plus R2. That is how we can shift this point, right? But generally this is very complex one, so we don't use it. What we use is, we simply convert that to SFG. If like we have to reduce in terms of adder, right, the block diagram becomes very complex. So what I used to do was usually solve with the signal flow graph. That method will be taught to you in the second lecture. So this is what for this case. Now shifting of takeoff point after the adder. So we have the takeoff point here, we have to shift it here only. So this time you guess what we need to do. So here we have the output R1 and we want to shift it to here, okay. So what is the output here? It is R1 plus R2. It is R1 plus R2, okay. So what do we need to do, like to get R1, right? What do we need to do? We have R1 plus R2. Think about it. So we need to simply subtract this R2, right? So what I will do is simply add a subtractor this time. Instead of adder, I will add a subtractor this time. So let me copy this again. What I will do, I will take the output from here, okay, then we'll add this, but we'll subtract this R2 because we have one extra R2 term. So what will be my output? R1 only, right? Because R1 plus R2 minus R2 becomes R1 only. So this is my output. Okay, sorry, light went off. Sorry, actually the light went off, so again I had to restart the recording. Previously I think there was a bit of noise because I was recording the audio a bit incorrectly, so just sorry for that noise issue also. So we were here only, right, that if I want to shift a takeoff point after a adder, right, then what do I need to do, right? So this is basically we have to use a subtractor, right, and then take off from there, take off from that point. Now what I want to do is I want to interchange the adders. I want to make this here and this one here. So I want to interchange them, right? I want to put this here and put this here, okay, to interchange these two. But after interchanging, right, my output right here at this point should remain change. So like what do I need to do for interchanging the adders? Can I simply interchange them, or do I need to do something else? Think about this. I can simply interchange them, right? Because this output, right, what is this output? This is R1 plus R2 plus R3, right? So this output, even if I interchange, right, this is the adder 1 and this is the adder 2. So what I will do, I simply interchange these two, okay. This I write as R3 and this I write as R2, okay. So what do I get here at the output? Still the same, right? R1 plus R2 plus R3. Here also I get the same, R1 plus R2, R1 plus R2 here, and R1 plus R2 plus R3. Output remains same. So simply we can simply just swap them. We need to do any more modifications, right? Okay. So one thing to keep in mind is that if there is like a subtractor, right, a subtractor, then also we can interchange them, or what we can do is we can also combine them, right? What I can do is write this in a single block. So let me again copy this. Instead of interchanging them, what I can do is take it here and simply I can add like here also, right? So this is also one more method. What I can do is simply combine, okay, into one single add. Both of them mean the same thing only, okay. So again, if there is a subtractor here also, then also I can simply interchange them, okay. If there is adder, subtractor, whatever may be the case, I can interchange them. Just this output should remain same. Okay, let's go to the next rule. So the next rule is shifting of adder before a gain block, right? Before a gain block. So I want to shift this adder before a gain block, but this time I'm not shifting the takeoff point. What is the main point to note here is that the output at this point, right, the output at this point should remain change. If I shift this adder here, okay, the output at this point should remain same. So what is the output at this point currently? It is R1, right, times G plus R2, okay. This is the output at this point, right? So now what I should do is, like, if I want to shift this adder here, what will be the output of this adder? Let me draw this. You also think by yourself what components we need to add, right? So let me copy this. Okay, okay, I shouldn't have copied the okay, still I will like this only. Yeah, I will put it this here, put this here, this one will come here, this one will come here, okay, this one will come here, this one will come here only, and this one will come here only, right? Yeah, so simply if I do R2 here, what is the output I am getting, right? What is the output I am getting? I am getting R1 plus R2 times G, which is not our desired output, right? We needed, actually we wanted R1G times R2. So there is one extra gain with this R2 term, right? We have to eliminate that. What I can do, put a gain block here, and that will eliminate that. Now what will be the value of that gain block? It will be simply 1 by G2, right? So 1 by G simply. So if I put a gain block here, put a gain block here, then our output will change to sorry, will change to R1 plus R2 by G times G. So we will get our desired output. So this is the rule that we need to follow. Don't need to remember all this, just know all this, okay? Have a practice with all this, then you will be able to solve this directly in the question, okay? So yeah, this is what we need to do, put a gain block at before, right? Now it's the opposite, right? We have to shift the adder in the after the gain block, right? After the gain block. So how will I shift the adder after the gain block? So basically, right, this what is the output this time? This time, right, the output is R1 plus R2 times G. Now if I shift it after the gain block, okay, let me copy the previous okay, this one is already copied, right? Yeah, okay, this one is already copied. Simply paste this here. Yeah, it's like this scenario only. I am shifting the adder after the gain block. So what is the output I am getting this time? Output I am getting is R1G plus R2. But what do I need? I need extra gain, right? Extra gain in the coefficient of R2, that is R2 times G. So what I will do, again think, right? I will simply okay, let me like indicate that we want to do here. I will simply add a gain block, right? Simply add a gain block. So what I will do, and what will be the magnitude of the gain block? It will be G. It will be G. Okay, so this will get changed to C equals to R1 G plus R2 G. So C equals to R1 plus R2 times G. Okay, so this will be the gain block basically. Now this will be the modification, right, that we need to do for shifting the adder on the after the gain block. Okay, so now let's solve a few questions. So this is the first question. So like we have to find C upon R, right? So I have forgotten to write the question. Basically find C of S upon R of S. Mostly like this will be the standard question, right, for block diagram reduction. So first we will solve this using two methods. First will be the block diagram reduction method, and second one will be the equation, right? Writing equations, taking an unknown and writing equations and solving that. So first what you need to do is like understand that how can I reduce this, right? Just think of this, like can I move some point, or can I see some parallel connection or like some cascade connection? Can I see that? Okay, think about it. Okay, you thought. Okay, so now what I will do is I will copy this, right? Copy this, take here. The problem with block diagram, right, is you have to like draw the block diagram again and again, so it becomes a hassle, and like exam it consumes some more time. So the second method that you will see, whatever suits you, you choose that. Okay, what I used to do is like choose the second method, but you see whatever suits you, right? So this is the method one, block diagram reduction technique. Okay, BDR. So what I can see here is the same point is going here and going here. Okay, so these two are connected in parallel, right? These two are connected in parallel only. Okay, so what I can do is replace this to one block, but this is still here, right? This connection is still here, so this connection will still be here, but these two, right, these two I can replace with one block only. What will be that block? Parallel connection. So 1 by s plus 1. So I will okay, reduce the size of this a bit, this one a bit. Okay, then what I will do is I will not delete this, I will delete this block, okay, this adder, and I will replace this, right, with 1, because this is getting added, right. Okay, let me use another color, let me use thinner pen. So this is okay. So this is that. Now what, how can we reduce further? What can we see? How are these two blocks related? They are connected in cascade, right? So what we can do is simply multiply the s, right? So again, copying this. For me it's easier just to copy paste, but for you, you have to like keep on drawing again and again. You just can't like do over the that thing, previous thing, right? Then you will make some mistake or error, right? So keep in mind of that. So I will replace this to a single block, and what will be the value of block? It will be s times this, right? So it will be s plus 1. Okay, so it is s plus 1. Now how are these two related? What I can see is simply these two are connected in series, right? So simply again I can replace this whole thing, right, this single block. Replace the adder, bring it over here. Okay, this goes over. Okay, this is C of S only, and this block, right, simply 1 is getting added, right? They are connected in parallel. So okay, s plus 2. So what will be C of S upon R of S? So C of S upon R of S will be s plus 2. Okay, C of S upon R of S will be s plus 2. So this is one method to solve this. So how many steps we have to take? This first step, right, then second step, then third step, okay, then fourth. So we have to take 4 steps. Now the second method that I will do is using simple equations. So I don't have space, I will use simple equations, right? So equation, okay, I will copy the main block diagram, and we don't have to keep on drawing the block diagram right now. We can simply do our rough work over the block diagram itself. So what I will do is, now I will write over the block diagram itself. So I will make the block diagram a bit bigger for us to better understand that, like this is R, right? This point is R, so R is coming over here, so R is going to here and here also. So this is also R. I will just write R. I will ignore the S right now, okay, for our for ease of our like writing and analyzing. So this is also R. So what is happening here, right? What is coming? This is also R, right? So here we have R by S. Now what is the output here? These two are getting added. So what will be this? This will be R by S plus R. Now we are multiplying this with this gain block, right? So what will be this output? This output will be R plus RS, right? Now we are adding this with this one R, right? So what is our output? Output is R 2R plus RS, okay, and this is what we are taking as the output. So like as you can see, I didn't need to draw it over again. I just write it over the diagram and simply solve it. So our C will be R S plus 2R. So C by R will be S plus 2. Let me use different color. Okay, S plus 2. So I will write S over here. So like exam also you do like this only. Exam, so you don't need to even write S, because this is for our internal understanding. This is a function of frequency. But in exam, why will you waste time to write s, right? We need to waste time, we have to save our time, right? So that's how you'll solve in exam, okay? But in your subjective paper, obviously you write bracket s every step, right? But we are solving for gate, right? We want to crack gate, that's why we'll write just this bracket term, okay? So yeah, we got it. So both methods we got s plus 2, but this was like, sometimes this may come in handy, sometimes that may come in handy, and sometimes you have to use combination of both of them, right? What do you do? Reduce the block diagram, right? Complex block diagram to further simpler, then you use the equations. That combination you can also do, or the opposite you can do, like first use equation then reduce. No, first use reduce the block diagram, then use equations, okay? So this was the method 1. This was the question 1. Let's come to question 2. So this is the gate quotient, right? It is given that for the system shown in the figure, okay, there is a system shown, block diagram is shown, we have to find the transfer function, basically y upon x, okay? So what we can do is, you can use two methods this time, okay? So the block diagram reduction method I am giving you as homework, okay? That you have to do, like what you can think of here is, either bring this here, okay, either bring this here, or do something else. How can you reduce this further, okay? What I will do, I will solve this like equations only, okay? Few things you need to do by yourself also. So this is my block diagram. So what I will do, like I have x over here, right? X is coming over here also and here also, so we're writing x over here. Now I don't know the value of this point, so I will leave this point for now. So I will come back to this point. So I have x over here, now I have y over here, and this y, right, is y coming to here also. So now I know the value, so I will again restart here. So y is coming over here. So what is this subtracted block doing? Subtracting x from y, right? So what will be the output? Output will be x minus y. So now what we will do is multiply this x minus y with this gain block. So what is our output? Output is simply 2 times x minus y. Now what we'll do is simply add this, right? Add this is x minus 2x minus y, and this is x adding with this, right? So what do we get? We get 3x minus 2y, right? 3x minus 2y. So okay, get here as equals to y itself. So like this point, right? This point is 3x minus 2y, right? So let me write here, this point is 3x minus 2y, and which is equals to y itself, right? This point is y, okay? So now solving the equations, what do we get? 3x equals to 3y, and y of, now I will write s over here, okay? Y of s upon x of s equals to 1. So if you solve using block diagram, it may be a bit lengthy, so that's why now the homework is solve using block diagram, this system, right? Find the transfer function, basically. So we have another question. Now this one is a bit difficult question. So it is said that the block diagram of a system is shown in the figure. So we have to find the transfer function, right? C upon r we have to find, okay? So like how can we do it? Basically, right, first we will solve this using two methods. So this is a very big block diagram, this will take time, so we'll solve this using two methods. First one is simply block diagram reduction technique, and the second one is simply the equation technique, right? Taking unknowns. So what I can do is simply what I can see is here, right? This point is disturbing me a bit, because if I shift this point to here, right, this two will come in cascade and this one will come in negative feedback. So if I shift this point to here, then I can do something, right? So how can I shift this point to here? So what do I need to notice here is, I need to make this input to this block, right, same. Input to this block should be same. I will not remember any formula, I will do this directly in front of you, okay? So how do I, if I shift this after a gain block, what we used to do, okay, remember that. If you can't remember, then we'll solve this directly here. So let's say I have one signal x over here, let me draw this like this, x over here. Just hold on a second. Sorry for the interruption, actually bell rang and someone came to the door. Okay, so this point is x. If this point is x, so what is this point? This point is x times g2, right? So if I want to shift this point to here, now what will this become? The input to this block become, it will become x times g2 times g3. So one extra g3 is coming. So what do I need to add here? I need to add an extra gain of 1 by g3 that will cancel this x times g2, right? So that is how I will add this, right? So if I shift this here, we have to add one extra 1 by g3 to like oppose the effect of this one, right? Oppose the effect. So what I will do again, okay, paste this here. This is the issue with block diagram, right? So paste this here. Now delete this. And connect this point, okay, with this block. And what I will do is, okay, this may seem like this is not connected, but this is connected. Okay, I will delete this. Okay, divide by g3. Okay, this is also getting thicker. So h2 by g3 will be our this answer, right? So this one will change from h2 to h2 by g3. Okay, so now I can simply use the negative feedback loop, right? Negative feedback loop, and replace this. Firstly, this is in cascade, so what will they become? They will become g2 times g3. Now I will use the negative feedback. So again copying this, right? I will replace this block. So how to replace this? Simply write here, this part is g2 times g3. Okay, this part is g2 times g3, and this is h. This is the feedback gain, and this is the forward gain. Okay, so g2 times g3 divided by 1 plus g2 times g3 h1. So this whole combination, right, will be replaced by this one block. Okay, so let me paste this again. So I can replace this whole combination. Okay, so what will this combination become? So this will become g2 g3 this g2 g3 by 1 plus g2 g3 h1. So g2 g3 by 1 plus g2 g3 h1. Okay, again someone came. This time someone else will open the door. So okay, so this is the block. Now what I will do, simply multiply these two, right? They are connected in cascade. Then I will again use the negative feedback formula. Okay, so again copying this. So this one will be right. This whole combination will be g1 g2 g3 divided by 1 plus g1 g2 no g3 g2 h1. Okay, so like again I will use that formula only. So write that formula only. So this time I will write directly now. Okay, I have you understand this. So g1 g2 g3 divided by this denominator, right, comes to which gets multiplied by 1. Okay, so you can write this directly also, 1 plus g3 g2 h1. Now plus that g into h term, right? So this is the one term that is getting multiplied by the denominator of this one. Okay, we're multiplying the numerator and denominator by this term, right? That's how I'm getting this. Now what will this will be simply g times h. So this will be g1 g2 g3 times this h2 by g3. So we are left with G1, G2, and H2 by G3 is simply H2 only. Okay, so this is our gain block. So like you do the multiplication, you will understand what I am doing. Okay, I will explain you also what I am doing. So this whole G, right, this whole G is equals to this one only. This is the whole G, which is equals to C of S by what was this? This was, yeah, C of S by R of S. So what I am doing, basically the formula, right, formula is C of S by R of S equals to this, like not this formula, G upon 1 plus GH, right? So if they are in reciprocal form, right, not reciprocal, if there is some fraction here, so I will multiply the numerator and denominator by both of them. Now if one is multiplied by that, so that whatever term is in the division term, right, in the denominator term, that will come here, and this G into H, the denominator of this G will get cancelled, and simply the numerator times this H will be remained. That is what I am doing here. So this will help you time in the exam, so you can save time. Okay, that is the method that I used to use when I need to find like this and we have a big forward path gain. Okay, you can use this. So yeah, this is the answer for this one. Now what I will do is simply use the equation, right, method 2. Using equations, right? So now I will again copy this whole block diagram. Copy this whole block diagram. Now what are the known terms to me, right? So here I am saying I have R. I don't know what is the term here, right? But I know this term C, right? So if I assume this as X, right, let's say if I assume, I can directly write here C by G3, but you will ask me how is this C by G3. So what you can do is assume this X here. So this X, right, X times this gain block equals to C only, right? So what is X equals to? X is C by G3. So you understood this. Now whenever you shift this here, you divide by G3, right? You divide by the gain of that block. Okay, so I hope you got it. So I will delete this and I will write here C by G3. Okay, so this point is C by G3. Now this is getting multiplied by H2 and getting subtracted here. So this is C by G3 times H2. So what is the value of this point? This is R minus C by G3 times H2. Okay, now what is getting, this is getting multiplied with this gain block, right? So this point is, we're running out of space, so this will happen. You have to make your block diagram, right, more and more bigger, so that you get enough space. Okay, so this point, right, this point will be simply R minus C by, okay, this becomes G actually, C by G3 times H2 times G1. Okay, this becomes G1. Now what is the value here? The value here is C, so C times H1. So C times H1. So we have to subtract this, right? We have to subtract this here. So I'll go to the next page right now. So I have to subtract. Let me copy this. For me it's easy, just copy and paste. So I will copy this, make this bigger, and also subtract this one, right? C times H1. So subtracting C times H1. Now what is the output of this? So I am multiplying with, like, I am passing this signal through gain block. So this is G2. Now what is the output here? Output here is C by G3. So if I subtract this and multiply this with G2, the output that I should get is what? C by G3. So I will multiply this with gain block of G2, and the output that I should get is C by G3. So what I will do is, like, divide this by G2 here, C by G3 H2, like we're left with H1 only. Okay, this I think should multiply by G1. This is C by G3. This is just algebraic calculation. you can do it for yourself also. So I will divide by r minus c by g3 h2 equals to c by g1 g2 g3 plus c by h1 g1. Okay, c by h1 g1. So yeah, this is the block. Now what I need to do is again take common over there. So r equals to this term, right, r by g3. So what I will do is simply g1 multiply g1 g2 g3, like common denominator is g1 g2 g3. So we have one common denominator, g1 g2 and g3. So what are we left with is, so this we have to multiply g1 g2, right? This doesn't have g1 g2, so taking c common outside, g1 g2 h2 plus g1 g2 h2, and this has everything, so we'll add one only. This is in bracket, right? And this, right, this doesn't have g2 and g3, so g2 g3 h1. So I hope you are seeing how am I simplifying this. So this is also important for solving in your exam, right? So how to simplify all this? So cs upon r of s we get as is g1 g2 g3. Okay, so this is 1 plus g1 g2 h2 plus g2 g3 h1. Okay, so yeah, this is what c by r is. So like I hope you understand, like whichever you found like suitable, you can use that all. Okay, so this was the solution for this question using two methods. Now again we have one gate question which came in EE 2014. We have to find the block diagram of a system shown in the, or not, like the block diagram of the system is shown. Okay, we have to find the transfer function. Basically forgot to write is c of s upon r of s equals to what? So again, like what you can do is simply either like use that block reduction technique, or you can do is use that equation technique. So first I will solve this using block reduction. Okay, the question is written, I forgot, sorry. So okay, the question is written actually. What is the question telling us is, okay, it has given us a transformation in terms of s, right? In terms of frequency it has given us a transformation. What we need to find is, we have to find the g of s, this g of s, right? We have been given the transformation in terms of s, so this g of s also we have to find in terms of s. Okay, so how will I do it? Firstly I will find the transfer function in terms of g and s, then I will replace g with suitable options. I will check which option is matching with our final transformation. Okay, so what I will do, whatever method you find suitable, you use that. Okay, first I'm using the block diagram reduction technique. Okay, so let me copy this. So what I am observing is this, how can you further reduce it? Just think about it, this, right? How can you further reduce it? So if these two are connected in product, right, and there is a negative feedback, so I can simply reduce this into one block. But the problem is there is some takeoff point here, right, in the between. So if I move this takeoff point here, then it will be easier for me to reduce this whole thing, right, negative feedback. So I want to reduce this here. Okay, I want to reduce this here. So if I want to reduce this here, so initially here we had x, right, but here I have x times s, so I need to divide this by s also, divide this point by s, so that this doesn't affect my inputs here, right? So don't mistake, like don't you do the mistake here that you replace 1 by s over here. What you do is, we have x here, right? So I will replace here only, I will use those blocks here only, that 1 by s gain block, right? I hope you are understanding. I'm just moving the takeoff point from here, so I will replace this 1 by s, like put a gain block here and here. Okay, so again, like let me copy this, so this will replace this is replace this with 1 by s and 1 by s. Okay, so what we'll do is bring this here only, right? Bring this here only. So this will be this one. So now I can further reduce this, right? So this is in cascade, so this will be s times g of s. So I can just delete this. Okay, I'm doing this here directly. Okay, for you it's not a privilege, you have to again redraw. So g, I will just simply write g right now for easier. Okay, g times s. Now what again I will do is replace this with like a single block, right? This one is a negative feedback, so I'll replace this with a single block. This will be gs by 1 plus gs. Okay, because h is 1. So okay, now okay, let me again, this negative feedback, that's why we use this formula. Okay, now what I can do is, like again what is happening here is, we are, these two are this is like a negative feedback only, right? This is like a negative feedback only. So what I can do is again replace this, right? This is like a negative feedback only. Okay, I hope you are seeing this. Okay, so what I can do is replace this with a single block, because this is like a negative feedback here. Okay, so again copying this one, deleting this one. Okay, deleting this subtractor. So what will be the like the value here is that, again I will use that short trick, right? So g of s, now we have 1 over s also. So what I will keep in mind here is, this will become as 1 over like 1 plus gs. Now gs times 1 over s, so we're left with simply g only. Okay, simply g only. So you understand how am I writing this directly? Okay, so this will get replaced. Okay, here only one extra g term will come, right? Only one extra g term will come. Okay, here plus g, right? Only one extra g term will come. Okay, so again this is again block, cascade block. Again we have a negative feedback. Okay, again we will do the same thing. We'll do the same thing. So like again, like these two will multiply each other, so we will get 1 by s multiplied by this, will be left with only g at the numerator. So it's easy for me, I can just delete over here. For you it's not easy. Okay, now simply use the negative feedback formula, right? So how to use that? Simply this time, right, the numerator will be g only. Okay, then 1 plus gs plus g, plus what you have to do is this 1 by s and g by s we have to multiply, right? So now this is up to you how to do the algebraic calculation much faster. So now I will multiply s, like I will not multiply, I will just keep it over here. Okay, then I will compare with the transfer function that is given. The transfer function what is given is this one. So if I compare that, right, now if I put like the numerator I can see is s, if I put g equals to s, then this becomes s. Okay, fine, it matches. Now this, right, g times s is s square. Okay, we have coefficient of 1. Okay, fine, s is okay, coefficient of s like s is 1 also. Here s by s, so this is 1 and this is 1, so 2. Yeah, so g should be equals to s only. So don't mind if I write the g like this. Okay, just try to understand, but but so I'm doing rough only. So g of s should be equals to s. This is the answer. Okay, so g of s should be equals to s. Now we'll solve this using the method 2, that is basically the equation method, right? So again, let me take this block diagram. So what will it be? So what I will write here is, like, I don't know few stuff. So again, what I can do here is, this is C and this is S, right? Gain block. So I can write here C by S. Okay. Now this C by S is coming to here also, here also. So C by S and C by S. Now this point, right, is R minus C by S. Okay. Now we are multiplying this with 1 by S. So what is our output? Here is okay, this is R by S minus C by S square. Okay, now again, right, we're subtracting C by S over here and we're subtracting with C over here, right? So what is the output here? Let me draw in different colors. So this is very difficult right now. So okay, R by S minus C by S square minus C by S, and we're multiplying with this gain block, right? We're multiplying with this gain block. So R by S, this is g of s only, minus C by S square minus C by S multiplied by this gain block, right? Okay, g of s, this whole is getting multiplied, okay, which is equals to this C by S only, right? So I will copy this, I will solve this equation right now. So I hope you are understanding how is the flow, right? How is the flow? This is only with the flow, right? So copy and paste this over here and enlarge this times g of s. This times g of s is the output here, and this output is equal to C by S only. So C by S only. So let us solve this equation right now. So solving this is a bit difficult. Okay, so what I will do is, this is R, I'll separate R and C times G. I will just simply write G right now, okay, not write S. And we have, I will take all the C's over there. Okay, G I can divide, right? G I can divide. So what I can do is, this becomes C by G times S, just algebraic calculations, and this becomes C by S square. This becomes plus C by S, right? So I will take C common and find the ratio C by R. So C by R is like, this will go like okay, let me don't do this directly. This is R only, and I will multiply S right now. So S, so C I will take common. This becomes G plus 1 by S plus S plus 1. Okay, so C by R equals to, simply if I divide this, right? So yeah, again if I cross multiply this, so this becomes S is on the numerator, and we have G times S plus 1 plus S square plus S again. Okay, so what will be the value of G this time? Okay, so if G is equals to, okay, that's what the mistake was. This is 1 by G only, right? This is 1 by G. I made a mistake over here. So this will be S by G. Now it is correct. That's why I was getting confused. So if this G equals to S here, I will get this equation, right? I will get this equation if G equals to S. Okay, so do I have space here? I'll get this equation. Okay, so again, option B is correct, right? So this is how you can also solve it. Okay, but this one is what you don't need to think about much, like which blocks to reduce and which blocks to not reduce. You can go directly. Okay, also you don't need to draw the block diagrams much, but in block diagram you have to draw it again and again. So it depends like which you find more suitable. Okay, so yeah, this was it for this question. So we have another question. Where is that question? Yeah, this is the question, right? So this one is a bit difficult. This one is the last question also. What I will do is give you this as homework, right? The homework is the block diagram of a system is shown in the figure. So you have to find the transfer function C upon R. You use both of these methods using the block diagram reduction technique and the what do you say, the simple equation method, right? So let me give you a quick recap of this lecture, what we did in this lecture. So firstly, we learned like why do we need block diagram reduction, because we have many subsystems and we want to analyze them much more in a easier manner, right? So if we reduce this into one simple transfer function, so it will be easier for us to analyze, find the time response and all those things. What is time response and what is steady state response, all those things we'll learn in next few chapters, right? So yeah, then we learned about different block diagram reduction techniques. So what is block diagram? We learned reduction techniques. Main thing is you have to make whatever output we are getting, right? Like the takeoff point, that should remain same. So closed loop, we already knew this, right? Closed loop for feedback, positive feedback and negative feedback. But here whatever the output we are taking should be same. Like if we want to change for cascade and parallel, we already knew this. Okay, the main thing is this one, right? Takeoff point. If I am taking off from here, the output whichever I got from here should remain same also here. Okay, that is the more important thing. Okay, so yeah, if I want to shift here, then also the output I am getting here R, so I should get R here. So we have to divide. So basically the gain block will be 1 over G, inverse of G. Okay, so yeah, all these things I have told you. One thing just keep in mind, if you have too many of adders and too much of adders, what you can do, either use the equation or you use the signal flow graph. Okay, that's what I used to do, because I found it a bit difficult to solve with adders and use the block diagram reduction technique. Okay, so yeah, interchanging, all those things. The main thing is that in your head should be kept is that the final output should remain same here, right? That is the main important thing. Okay, so you don't need to remember all this. No, I don't even remember all this, right? So yeah, this is the main thing. So we did few questions. So yeah, that is it for this lecture. Thank you for watching.